start also recording. And I hope everybody is well. How is it going? We can start now. And who wants to start first? And after all of you explain what you did, and I will explain what should we do in the next step. Yes, who wants to start? Is there anybody who wants to start?
Yeah, maybe we can start with
Okay.
after the recent events. Now we are in group of 3. Me,
Yes.
Gabriela, and Emre,
Yes.
and we are trying to read and understand the papers you sent about age detection.
Yes.
As we discussed before, we maybe try to use age detection and use it in the 2 directions. So edges in horizontal and edges in vertical, and try to see an intersection. Then we may use that as a corner detection.
Yes.
Actually, if I recall, that is also one of the fundamental steps of the Harris corner detection too. So maybe we can directly move to the another step after finding gradients or basically edges. And also Gabriela found another paper also is about finding edges in image by using quantum image processing. Also, we'll try to give it a look and to see if we can find something useful from that one too. Also, we can share that paper in our common group too. So other group may also try to see if it will be useful or not.
Okay. Okay. Everybody can share what they found on literature or what they are did by coding. Everybody, I expect to share their works on Discord because it's so important and time closing. And also, thank you for your information and explanation.
Thank you very much for listening.
Okay. What is the other group who wants to start? Mohammed?
Yeah, hi everyone.
Hi.
Maybe Inge, can you share your screen?
Yes.
So we implemented the quantum Harris corner detection algorithm using this the Hadamard edge detection technique. So this is our the QPI encoding function,
Yes.
which we also showed in the first week, and then we tried the the corner detection with this image, which is the shapes of stars and the square. And then what we did is we applied this key, the quantum Hadamard edge detection algorithm. Can you go down further? So in that, we also have to include this unitary, which is the permutation unitary. So using this permutation unitary, we kind of get the edge or the derivative of the images, both in the horizontal and the vertical direction. So here we have both the circuit for the horizontal and the vertical. So below we have the circuits here. So this unitary is the permutation unitary that is used in the Hadamard edge detection technique.
Is
And
it,
then
sorry, upper side, can you share, I want to see picture. Okay.
Yep.
This unitary function is the swap test?
No, it's not swap test. It's the permutation unitary. So it's kind of shift the amplitude in a circular way. So if we have in the vector, if we have the first amplitude, which is corresponding to 0, 0, 0, 0, let's say the basis, then it shift it to the 1, 1 basis. So it's kind of circularly shift the amplitude from top to bottom.
Okay, I read on the paper. Yes, I know.
So that's the unitary that we implemented. Also, Shimge also tried the other representation of that unitary, which is using the control X gate and the X gate. So control X gate and the X gate both. So we also tried with that and it's worked, but we kept it the unitary because in the paper it was mentioned the permutation unitary. So can you go down so further? So this is the image of the derivative. This is not the edge. This is just the derivative. So the first image here is the x derivative. So here, if we can see clearly that in the first horizontal derivative, we have the vertical lines. And then when we are taking the vertical derivative, can you go up? No, down. The horizontal and the vertical scan output. Yeah, here.
Yes.
So if you see in the horizontal, when we are taking the horizontal derivative, then our lines are vertical. That makes sense. And similarly, when we are taking vertical scan output, then we are getting the derivative. Then we are getting the horizontal lines. Can you go down further? Yeah, and then finally we have the superimposed of both the vertical and the horizontal. That is the edge that we get from this original image. So till now we have only the derivative in both direction, vertical and horizontal. Now what we are doing is we are applying the classical post processing on this derivative. So the quantum circuit, it's kind of parallelizing the derivative thing that we can easily get. And now we are using this derivative to get the corners. Can you go down? So we have horizontal derivative and the vertical derivative. This is just replotting again the same thing, but with the colors. Can you go down?
Vertical derivative.
And then here we are applying this classical post processing of the Harris corner detection. We are trying to compute the matrix, the Harris matrix, and taking the value. If that is greater than some number, then we are detecting that as a corner. Can you go down the last image? So here, these are the kind of like corners that we have detected, but these are really hyperparameter dependent. If we change the block size to 4, we tried different things. If we change the block size to 4 instead of 6, then we can easily get uh, the corners of the first image also, the first square also, which is on the top left. And changing the value, the threshold of the R, that is the Harris corner detection matrix, then also we can make these corners even better. That we tried for 3-4 different hyperparameters.
Okay. Thank you for your efforts, and thank you. And I guess Simge, Asude, and you implement together. And thank you, all of you.
Yeah, so we all contributed to this code.
Thank you. Uh, I want to say after that, I don't know, before the meeting you implement, all of you implement corner detection or not implemented, get the results, true result or not. I don't know. Maybe for now, maybe by the next week, you can complete the corner detection part. I guessing it can be or not. Mohammed?
Yeah, so we will complete by the end of this weekend.
Yes, thank you. And yes, as I said, I don't know how is going the process, but I think we can start first. Sorry, and sorry, I will explain now. I'm searching. After that, yes, everybody know that our project purpose is realizing corner detection part by using machine learning. And I don't know we can complete or not complete. Everybody knows time is closing, but I want to share. Sorry, my screen. Yes. I found this paper. Yes, by now we implement. This is the example of our purpose model. And this part of the model is to complete the corner detection and extract feature. And this is the convolutional part. But our purpose is, as you know, is the detection of the corner. And after that, we extract the feature of the corner, get the train model by using this feature. But I don't know we can realize or not by the end of this QIntern term. But we can start to write paper by opening Overleaf on the Overleaf project. We start to write paper, but as I see now, we can present this work. Only corner detection part is okay for me for QIntern project. But if we realize this model, we can publish a good paper. If you want, we can continue after the QIntern term finished. If you want working together, we can realize this part. And I don't know everybody wants or not. Is only ANN part. QANN part by using these features, corner features. And after we can classify this is a rectangle or triangle or circle. I think we can do that after corner detection part we complete. What do you think about that?
Yeah, to me, I'd like to continue to end this work as a paper in a conference or a journal. So
Yeah.
I'd like to keep working with team.
Okay. Everybody say okay. As I said, and for QIntern, realizing for every image encoding model and detection the corner is okay for QIntern project. But after, I want to continue realizing QANN parts by using corner detection features for classify the images. And okay.
Mm-hmm. By the way, Dr. Kochak, I have premium Overleaf account, so I can create a project that I can add as much as people to collaborate on the same project. Because normally, for unpaid accounts, only two authors can collaborate.
Yes.
So I can create the project and send invitation to you, to all of the members.
Okay, thank you. Also, I want to ask to all of you this question. Thank you. You answered before. And okay, everybody is okay. We can continue, and other groups continue. If Mohammed share their codes on GitHub, and everybody try to implement this code by using their image encoding model and for corner detection. If this week we can implement this corner detection part, we can pass the ANN parts. Okay?
Yeah, that's cool.
Okay, it's good. Thank you, all of you, for your efforts. Is there anyone wants to say something, ask something? I also share this paper, all of you. It's very nice. Quantum machine learning for image classification. It's so good. It's also for our purpose. And we can use for next section this paper.
So until our next meeting, we are going to adapt our own encoding, image encoding methods.
Yes.
To the codes which Mohammed has written, right?
Yes. Yes.
Okay.
Embedding
Okay,
your image encoding model to Mohammed's code. Okay.
All right.
Everybody share their ideas, what they found on the literature, any ideas for corner detection model, and anybody wants to implement any corner detection models, and everybody can share on Discord. Don't afraid from writing your ideas or your codes, and our purpose is implement as far as implement the code project and publish a paper. Okay. And firstly, for writing paper, we can write our encoding model after the introduction. Maybe you can write a literature review, what you find on paper briefly in the introduction section, and after the method section, everybody writes their encoding model. Everybody explain their encoding model. After we can pass the corner detection model, and if we realize the QIntern model, we can write the final section to ANN model, and results we can write everybody writes. Okay.
Yeah, no problem.
Okay.
Yeah, I have a question.
Yes.
So, considering the corner detection right now needs to be done post process because it's the circuits, maybe it wouldn't be interesting to try to implement, because as going back to what Han said previously, I found that one of the PhD papers said that there's a way when you use a ancilla qubit to implement both the horizontal and vertical
Yes.
circuit together. Would it be interesting to know, maybe we can try to implement this version and see if we could do the Harris algorithm inside the quantum circuit? Maybe just to like see if it's possible. I don't know if about the time limits allows for it, but maybe it was a possibility to, if you can put together both of the vertical version and the horizontal version and compare them, and maybe in the exactly on the circuit itself become the corner detection. Maybe it would be, if it's be interesting to try to explore this possibility, even considering that the other group is even ahead of us this week, because we actually had to restart all over again, so we didn't improve as much. Maybe it's possible to try to implement something like that. I don't know.
Yes, it can be. I don't know. But our data set is not feasible for model because there is handwritten shapes. Because of the handwritten data shapes there is, and there is some lines is not straight. And so yes, I think your model, but when I try to implement, we get error. Some, because as I said, lines not totally straight, and so I'm getting errors. And after that, I think I can create data sets. Maybe everybody knows on the GitHub and circle data set, and 50 circle data set, 50 triangle, 50 rectangle data sets to implement your model, your said model. And I don't know the results. Maybe you can implement. If you have enough time, you can try. It doesn't matter for me.
Okay.
So
Okay.
I would like to add a few comments about the quantum Harris corner detection technique.
Yes.
So so we can so the Harris corner detection scheme, it consists of computing the determinant and computing the trace. So that will come into the classical post-processing technique. If we try to implement those into the quantum circuit, there is no uh, quantum advantage or sense that we can get from the quantum circuit. The only use of the quantum circuit is basically to compute all the gradients at once. So if we can do that, then there is a quantum advantage. But after that, I think we have to do the classical post-processing. Also, I went through some of the papers, and then I feel now that if we implement the FRQI image encoding technique for the for the Harris corner detection, then uh, it will not be easy. It will be tough, but we can try with the other representation, that is NEQR. I think that can be done. So this comment I had that I saw in the other papers while I and Senge, we were reading.
Yeah. So, but I honestly believe that implementing on NRQ could probably be some challenging as well, because NRQR is binary and this Hadamard will act on the qubits phase, so amplitude actually, sorry. So I don't know also how easy it would be to translate the NRQR to a phase related or amplitude related encoding. So I don't know how easy it would be to implement the NRQR. I saw that there's some paper that said that there's a way to do it, but I don't know how realistically how easy it is to do that.
So I don't think so that we can apply this Hadamard edge detection technique for any QR. The reason why I am saying this is for the Hadamard edge detection, we need the pixel value in the amplitude of the qubits.
Yes, exactly.
And then when we have the pixels encoded in the qubit, then the Hadamard can't do anything. The only thing that we can have is quantum adder, quantum comparator. So we have to build those modules, and then we can do addition and subtraction.
Yeah, I would probably be able to use something like a QFT, like the Fourier transformation, to turn into the amplitude, but I still don't think that would be advantage. So I also agree with you. I don't think it's possible to implement this method with NRQR. To implement the NRQR, we would either need to go back to the previous method or a new method, because this with Hadamard method, it would not be feasible to implement with NRQR exactly for being binary. So I don't know if we should just ignore NRQR or implement a different method to use with NRQR.
So maybe for using this quantum Hadamard QHED algorithm, we can try for the FRQI, and currently we have this QP quantum probability.
Yeah.
So we can try to bring these two encoding methods together, and this quantum Harris is again, it's not like a very great contribution, but it's like a small contribution that we can publish in some paper, at least for these two encoding methods. Coming to your NEQR method, I think I also got this idea of using the QFT, and I am also working on that. If we can use this QFT for the FRQI, and then something can be, maybe I will try to post something on the Discord, and then maybe you can comment. What do you think?
Yeah, the problem with QFT is that even if we transform it, the phase would be distributed in different qubits. So I don't know how can we, if we,
So
how easily it would be to
the
go all
idea-
this amplitude to one. That's my concern as well. I don't know
No,
how
we
easy.
can do, because I think the idea is the basic idea is so the derivative operator, the the differentiation kernel, which we use in the horizontal and the vertical scan, that is basically the convolution of the differentiation kernel with the image. And if we do the QFT of both of these image and the kernel, and then if we multiply that one and then again do the QFT inverse, then we can get something, because that's how the people, they try to compute the convolution between two matrices by converting them into Fourier transform, and then again doing the multiplication and then reverting back to the original domain by doing QFT inverse. So there
Yes,
is
yes. But the thing is, the Hadamard implementation uses only one, the gradient is encoding in a single qubit. With KFT, you not necessarily encode it in a single qubit. Usually it remains the same amount of qubits before. So example, if we use 8 qubits to encode the gradient, after the QFT, we will still need to use 8 qubits. So we need to adapt part of the algorithm anyway, either using Hadamard in all of them and testing how this implementation would work, or doing a way to adapt it to different ways. So the thing, it is possible to encode, use a KFT to use matrix, but the KFT will remain with the same number of qubits. That's my problem. Like in the KHD, the Hadamard is applied in a single qubit. The gradient is on a single qubit. With NOQR, even after the QFT, we will still have the gradient implemented in 8 qubits, considering a grayscale.
Yes, so that will, yeah, I think that will require more number of qubits, but I think that can give us more maybe flexibility. I don't know, maybe that is more because that one is using more qubits, so it should give something
No,
more.
yeah, I agree. I just don't think it would be necessarily easy to do. No, I don't think it would be as direct as the FRQI version of it, that we just need to adapt it, but it's relatively the same circuit.
Yeah, that's correct. It's not trivial.
Thanks. Okay, but edge detection by using QFT, there is so many implementation I saw on the literature. Did you see? For edge detection.
No, I didn't research about it, and I was more focused on this paper presented. So no, I'm sorry, but
Yes. Okay,
I
maybe
can try
I
to
can
look at it.
share. Maybe I can share with you. Okay. Is there any question? A meeting. Okay. I finished the meeting. This meeting. Thank you for all of your attention. See you next week. We can continue to speak on Discord and share on Discord. Thank you. Goodbye.
Thank you very much and have a good weekend.
Thank you. Bye bye.
Yeah. Have a nice weekend.
Nice weekend.